To do its job properly, the ECU relies on signals from a range of inputs to tell it what the engine's doing. These inputs may include airflow into the engine, throttle position, manifold pressure, and air temperature, just to name a few. We may also have some digital inputs configured for controls such as air conditioning, power steering, or driver controlled switches. What we want to do is individually test each input to make sure that it's functioning correctly and the ECU is receiving the correct information. We're going to go through this process now and check each input. Let's start with the throttle position sensor. We can go to the throttle pedal setup sheet and we can see that the throttle pedal sensor resource is allocated to analog voltage input 4. If we go to the throttle pedal main offset and press Q with our foot off the throttle, it will enter the closed throttle voltage. We can now go to the throttle pedal main scale function and press Q while holding full throttle. This will set the throttle span. Once we've done this, we want to check that the throttle position is moving smoothly as we move the throttle pedal. While there are a number of ways of calculating engine load, the speed density principle is still the most common in aftermarket ECUs, and this requires a manifold pressure sensor, or MAP sensor for short. We can enter manifold pressure sensor in the All Calibrate menu, and this will bring up all the parameters and settings related to the MAP sensor. If we scroll down to the voltage resource setting, this defines which input pin the MAP signal is connected to, and in this case it's analog voltage input 2. Next, we can move up to the sensor calibration, and we have a table of MAP voltage versus pressure. If we press the A key, we can adjust the axis if required. Most ECUs will allow you to select predefined calibrations for most popular sensors. Once the sensor is calibrated, we want to make sure the reading is sensible. With the ECU powered up and the engine not running, we would expect to see a MAP reading of around 100 kPa, plus or minus about 5 kPa. Next, we're going to look at setting up an analog temperature sensor. Normally an intake air temperature sensor and engine coolant temp sensor will be fitted to your engine. For our example, we're going to look at setting up the engine coolant temp sensor. We can enter engine temperature in the All Calibrate menu, and this will bring up all of the parameters and settings related to the coolant temp sensor. If we look at the sensor voltage resource, we can see that the engine temp sensor is connected to the analog temperature 2 input. If we move up to the sensor calibration, we have a table of voltage versus engine temperature. In our example, this is calibrated to suit the factory FA20 temp sensor. Again, most ECUs will provide predefined calibrations for most common sensors. As usual, after configuring the sensor, it's time to check that the reading you are seeing is actually reasonable. The coolant temp and air temp on an engine that hasn't been running should measure approximately the same as your ambient temperature. If there's a difference of more than a couple of degrees, it's time to check your calibration. With a complicated ECU installation, you may also have a range of digital or switched inputs to perform certain functions. These inputs are quite simple and are generally either switched to ground or a high voltage when active. The important point here is to make sure that you have configured the polarity of these inputs correctly in the ECU and to test their becoming active when you expect them to be. For an example, we're going to look at the aircon request on the M150. This is actually generated via CAN, but the principle is still the same. If we go back to the All Calibrate menu and enter air conditioning, we get all of the relevant parameters. The aircon request resource is where we define where the request comes from. Currently this is set to not in use since the request is via CAN. If we click on it though, we have the option to select a digital input. Next we need to select the active edge the output will trigger on. This defines if the output will be active when the input signal goes from a high voltage to low, or vice versa. Lastly, we have the aircon request pull-up control. This turns the pull-up resistor for the selected channel on or off. This is used on signals that switch to ground to allow the ECU to differentiate between the input being high or low. Lastly, we can run the engine and test the aircon request as we switch the aircon on and off. We would repeat the same basic procedure for each different input. Once we've configured and tested the inputs, we can move on to the outputs.